So for this problem we want to find the particular solution for dy by dx is equal to minus 3 times y minus 2 over 2x plus 1 times x plus 2, giving our answer in the form y equals f of x, where y is equal to 4 and x is equal to 1. So we've got quite a few stages to this problem, but to start off with, as it's a differential equation, we need to separate our variables to get y on one side, x is on the other. Well, keeping dy on the left, the y minus 2 becomes 1 over y minus 2, and leaving the rest of the expression, so minus 3 over 2x plus 1 times x plus 2, the dx moves up to the numerator there. Once we've separated our variables, as with all these differential equations, we need to integrate both sides. So integrate and integrate. Now the left-hand side's easy enough to do. We're going to get the natural logarithm of y minus 2 is equal to. Now we will get a constant of integration here, but we'll take account of that in the final line on the right-hand side. But we need to integrate this expression, which is going to require a bit more work, because you might spot that actually we have some partial fractions we're going to need to make. So we have our expression minus 3 over 2x plus 1 times x plus 2. Fortunately, this is a nicer partial fraction part because there's no repeated factor or an improper fraction there, so we just have our two fractions, a over 2x plus 1 plus b over x plus 2. We multiply through by the denominator, so minus 3 is equal to a times x plus 2 plus b times 2x plus 1. To get rid of the first bracket, we can use x is equal to minus 2. So therefore, minus 3 is equal to, that goes to 0. 2 times minus 2 is minus 4, plus 1 is minus 3, so minus 3b. And therefore, b is equal to 1. To get rid of the second bracket, we can use x is equal to minus a half. So therefore, minus 3 is equal to minus a half plus 2 is 3 over 2. So 3 over 2a, that term goes to 0. So therefore, a is equal to minus 2. So we can substitute those into our expressions and then into our integral. So really we're integrating minus 2 over 2x plus 1 plus 1 over x plus 2 with respect to x. So we have the natural logarithm of y minus 2 is equal to minus 2 times the natural logarithm of the linear factor, 2x plus 1, divided by the differential of the linear factor, 2, plus the natural logarithm of x plus 2, and we can't forget our constant of integration at the end, our plus c. Now we don't need to write this as a natural logarithm because we have some values which we can substitute in, which will take care of that. Let's simplify this slightly and get rid of those 2's. So when x equals 1 and y equals 4, 4 minus 2, you've got the natural logarithm of 2, is equal to minus ln of 2 times 1 is 2 plus 1 is 3, plus 1 plus 2 is 3, plus c. Those natural logarithms will cancel, so c is equal to ln 2. So we can substitute in there. So you've got ln of y minus 2 equals minus ln of 2x plus 1 plus ln of x plus 2 plus ln 2. So we've dealt with the particular part of this, but we still need to get it into the form that they're after, which is y equals f of x. So we can combine these logarithms on the right-hand side to say that you've got ln of y minus 2 is equal to the natural logarithm of The pluses become multiplications in the numerator, so 2 times x plus 2, minus becomes a division, so divided by 2x plus 1. You can get rid of both of the logarithms by taking exponentials of both sides, such that y minus 2 is equal to 2 times x plus 2 over 2x plus 1. And then we can move this minus 2 to the other side, so it becomes a plus 2, y equals 2 times x plus 2 over 2x plus 1 plus 2. And that actually gets it in the form that we're after, and you would be fine to leave it like that. However, you might want to combine those so that this is all one fraction here. So we can do that. And we can multiply the 2 by this, so we've got a common denominator, multiply out the bracket, so you get 2x plus 4 plus 2 times 2x, so you get 4x plus 2 times 1, 2, all divided by 2x plus 1, 6x plus 6 over 2x plus 1, take out the factor of 6, leaving you with x plus 1 in the bracket, over 2x plus 1. So as a single fraction, y is equal to 6 times x plus 1 over 2x plus 1. Either this form or this form would be correct, but they might ask for it as a single fraction, so it just gives you a little bit more algebra there.